Okay, we're going to look at factorizing again. We're going to apply solving quadratic equations within a context. The first context will be some rectangles, and the second context will be graphs. So the first one, we have two rectangles, A and B. These are the lengths of the sides. They're expressed using x. And we're being told that the area of rectangle B is 3 squared centimeters bigger than the area of rectangle A. We're being asked to find the value for x that would make all of this true. So let me first translate what this sentence says into a very simple equation. The area of rectangle B is 3 square centimeters bigger than the area of rectangle A. So the area of A, let's write that here like that, plus 3 centimeters squared is equal to B's area. Yeah, so let's rewrite that, but instead of saying the area of A and the area of B, we'll actually we'll use the lengths of the sides. So the area of A would be length times width, right? Plus 3 is equal to the area of B, which would be length times width. Let's that side first times that one. Okay, and now we know to solve quadratic equations, which is finding the x values that make it true, we first want to get all the terms to the left side so that we have equals 0 at the end, right? I'm going to expand and then move stuff over to the left because then I can combine like terms. Let me show you how I do that. First, x times x, x squared, outer plus 3x, inner plus 1x, last plus 3, and then this 3 is equal to 2x times x, 2x squared, outer plus 8x, inner minus 1x, last minus 4. Because I have 2x squared here and 1x squared here, I'm going to actually move everything to the right so that I get 0 equals, because it really doesn't matter, right, if it's the zeros on the left or the right. But because it's set up like this, I'm going to now move everything to the right. So I'm going to subtract x squared from both sides, and at the same time combine these terms, 4x plus 6. And I'm subtracting the x squared, so I only have x squared plus 8x minus x. Oops, I could have combined those. I'll do that in the next step. I'm going to subtract 4x from both sides, so that I have 6 on this side. Subtract 4x from here. I'm also subtracting another x, so it's 8x minus 5x. Minus 4. Then I'm subtracting 6 from both sides. Negative 4 minus 6 is negative 10. Yeah? Now I'm going to factorize this. Let me rewrite it here. X squared plus 3x minus 10 is equal to 0. Let's list the factors of negative 10. I can use this space up here. Negative 10. We can get that by doing 1 times negative 10, 2 times negative 5, 5 times negative 2, or 10 times negative 1. Now I'm going to look for a combination that adds up to plus 3. That would be this one, because 5 plus a negative 2 is equal to 3. So I'm going to, of course, should have done this first. X times x gives that. Negative 2 plus 5. Then I'm going to set each of the factors equal to 0. So either x minus 2 equals 0 or x plus 5 is equal to 0. This would mean that x is 2, and this would mean that x is negative 5. This would usually be my answer, right? These two possibilities. But look, we were talking about rectangles. And if x is negative 5, then this side here would equal negative 4. The length of a side of a rectangle cannot be negative 4, so I'm going to let go of this answer and say x has to equal 2, right? We found x. We could also find the lengths of the sides. We're not being asked that, but we could. If x is 2, this side would be 2 plus 1 is 3. This side would be 5. This would be 2 times 2 is 4 minus 1 is 3. 2 plus 4 is 6. And then if because I like checking my work, right? 3 times 5, this would be 15 squared centimeters. And this would be 3 times 6 is 18 squared centimeters. That does make rectangle B's area 3 squared centimeters bigger than the area of rectangle A. So I must be right. X equals 2. Now I want to look at another one where we are where we have a quadratic graph and a straight line. The equation of the quadratic is this green one. That's why it's drawn green. This is the straight line. And we're being asked where the points of intersection are. What are the coordinates of this point and this point? Coordinates, so x and y value. This is a bit of a jump because we haven't done much with quadratic graphs. So I want to show you this with straight lines first. And to remind you that this is actually a situation where there's, what do you call that again? Equations, equations, simultaneous equations. Okay, with straight lines, say this is one of our lines, this is the other line. They're both straight lines. They're going to intersect at one point. If we were asked to say where that point is, what is the x and y value of that one point where they intersect? We could say we're looking for a point where their y values are equal and their x values are equal, right? So we can see them as simultaneous equations, and by using substitution, we could say, well, then x plus 3, we're going to substitute this y with x plus 3 and write x plus 3 equals 2x plus 2. Then we solve for x and we found the x value. Let's do that. Subtract x from both sides. Move the 2 over to that. Subtract 2 from both sides to get x by itself, right? That means x equals 1. Then when we plug it back in, we find the corresponding y value. If we plug in 1 for x here, then y equals 1 plus 3 is 4. So y equals 4. And our coordinate then would be 1, 4. We did this before. Another way would be just to draw the lines, right, and see where they intersect. If we wanted to draw the lines, we could make a table of values for this brown line and a table of values for the green line, which would be for brown when x is 0, y equals 3. When x is 2, y equals 5 when x equals, why did I do 2? When x equals 1, y is 4. Okay, they're not ordered very nicely, sorry. For the green one, when x is 0, y equals 2. When x is 1, 2 plus 2 is 4. When x equals 2, y equals 6. And we could even draw them. Draw the lines. 2, 5, 1, 4. This would be our brown one. This would be our green one, right? And this is where they intersect, which is 1, 4. We also could have noticed that in the table of values that they share 1 point, and that is the point where they intersect. But solving this using simultaneous equations, we remember we just set them equal to each other. We're going to say the y values are going to be equal. Where they intersect, the y values are equal. So we're going to set this equal to that, like we did here. Solve for x, then plug that in to find the corresponding y value, right? Now we're going to do that where one of the equations is quadratic. This green one is, right? So just like the previous one, we're going to say, okay, they intersect where their y values are equal and their x values. So we're going to set these two equal to each other. So x squared plus 4x minus 3 is equal to x plus 1, right? Simultaneous equations, substitution. We're going to move everything to the left, all the terms. So we're going to subtract x from both sides, which leaves us with 3x here. Now we're going to subtract 1 from each side. -3 minus 1 is -4, and we've got 0 left on this side. Now we're going to factorize, and we notice x squared, we know that we're going to have x and x here. Let's list the factors of -4. -4, we can get that by doing 1 times -4, or 2 times -2, or 4 times -1. Which combination gives us +3? Which combination adds up to +3? This one does, because 4 plus -1 is 3, so we're going to have a +4 and a -1. Yep, then we're going to set each of the factors equal to 0, so either x plus 4 is equal to 0, or x minus 1 is equal to 0. One of these has to be 0 for the product to be equal to 0, right? If this factor is equal to 0, that means x equals -4. If this factor is equal to 0, that means x is equal to 1, right? So we found 2 values for x that make these equations equal to each other, right? There's 2 values for x that make this equation true, right? So these 2 lines intersect at these 2 x values. All we need to do now is to find the corresponding y values, right? When x equals -4, what does y equal? We're going to plug it in. We can plug it into this formula, this equation, or this equation. We're going to do this one because it's easier. -4 plus 1 is -3, right? when x equals 1, what does y equal? 1 plus 1, 2. Y equals 2. So that would mean there's these two coordinates that make where the two lines intersect. One of them would be -4, comma, -3. And the other one is where x is 1 and y is equal to 2. These are the two coordinates where these lines intersect, right? It happens twice that the lines y values and x values are equal. Okay. And you can imagine all sorts of different contexts where we're going to have to solve quadratic equations in order to find answers. Okay. See you next time.